Welcome back to DevLand Diaries, where we dive deep into the world of AI, machine learning, and all things tech. I'm your host, Michael Kessler, and today we're going to talk about something really exciting, the Multi-Armed Bandit problem, and how it fits into the broader world of reinforcement learning. Now, don't worry, this isn't as complex as it sounds. By the end of this episode, you'll have a solid understanding of these concepts, and I promise I'll make it as fun as possible. Let's start with the multi-armed bandit. Imagine you're sitting in a casino, staring at a row of slot machines, each with a different probability of winning. You've got limited time and money, so you need to figure out which machine to play to maximize your winnings. Each machine is like an arm of the bandit, and the goal is to learn which one gives the best reward. You can't just try every machine forever, so you have to balance two things. Exploration, trying different machines, and exploitation, playing the machine that's giving you the most rewards so far. In the world of machine learning, this is called the multi-armed bandit problem. The challenge here is how to balance exploration, checking out new possibilities to find out which machine works best, and exploitation, where you keep going for the arm that's been paying out the most. This problem shows up in lots of places, like recommendation systems, online advertising, or even clinical trials. Now, the big question is, how do we solve this? Well, the most famous strategy is the epsilon greedy algorithm. In simple terms, epsilon is a small number that represents the chance that you'll try a new arm exploration, rather than going with the best one, exploitation. Or for example, if epsilon equal to 0.1, you'll try a new machine 10% of the time and exploit the best one 90% of the time. But here's the cool part, reinforcement learning builds on this idea and takes it to the next level. RL is all about an agent, like our casino player, interacting with an environment, trying different actions, and learning from those actions to maximize its rewards over time. The idea is that you take actions based on what you've learned and adjust them based on the results. Think of it like training a dog. When the dog does something good, you reward it positive reinforcement. And when it does something wrong, you either correct it or just let it try again. In RL, the agent gets feedback from its actions and uses that feedback to improve its future decisions. Let's break it down even more simply. The agent, the thing making decisions like our casino player, the environment, everything the agent interacts with, like the slot machines, actions, the choices the agent makes pulling the lever on the machine, rewards, the feedback the agent gets based on its actions, the winnings from the machine, policy, a strategy the agent uses to decide what action to take in a given situation. This can be learned over time to maximize rewards. One of the key components of RL is the exploration versus exploitation trade-off that we touched on with the MAB problem. In RL, the agent needs to explore different actions in order to learn, but it also needs to exploit the actions that are likely to give the highest rewards. This balance is crucial and can determine how successful an agent will be in the long run. To make this more concrete, let's look at an example. Think about a robot learning to play chess. At first, it might try random moves exploration. Over time, it will start to learn which moves lead to winning and which ones lead to losing exploitation. The more it plays, the better it gets at figuring out which actions to take in future games. Reinforcement learning is a powerful tool because it can learn from experience just like humans. It's great for tasks where you don't have a predefined set of rules and the environment is constantly changing, like robotics, game playing, self-driving cars, or even dynamic pricing in e-commerce. Now, a big part of RL is learning from rewards over time. There's this important concept of a reward signal, which essentially tells the agent how good or bad its actions are. The goal is to maximize these rewards, and one way to do this is through something called Q learning, where the agent learns the value of taking an action in a given state. It's like a brain workout for the agent, helping it figure out which actions will pay off in the long run. Alright, so to recap, multi-armed bandit. The problem of deciding how to explore and exploit when trying to find the best action like a slot machine. Reinforcement learning, a method where an agent learns from taking actions, receiving rewards, and adjusting its behavior to maximize those rewards. Exploration versus exploitation, the trade-off between trying new things and sticking with what you know is working. And here's the best part. Both of these concepts are foundational for a huge chunk of AI research today. They're used in recommendation systems like Netflix suggesting movies, marketing strategies like personalized ads, and even robotic learning like teaching a robot to walk. I hope this episode has helped clear up the basics of the multi-armed bandit and reinforcement learning. It's a fascinating area of AI that really helps machines make smarter decisions over time. So that's it for today's DevLand Diaries. I hope you had as much fun learning about MAB and RL as I did talking about it. As always, keep experimenting, stay curious, and I'll catch you next time on the next episode. Don't forget to hit that subscribe button if you want to dive deeper into the world of AI.